The second and third steps in defining a simulation models are giving the branching probability of every branch coming out of a decision gateway. This is very similar to what we saw in cycle time analysis. But in addition to that, we need also to define at what rate new instances of the process are being created. And that is called the arrival rate. And typically this is not a fixed value. It is not that instances are created exactly every 30 minutes, but sometimes it takes less time between two consecutive instances. Sometimes it takes more time. Therefore, we will model that typically using a probability distribution, again, in the same way that we did to define the processing time of activities. The most typical distribution for modeling the arrival rate of process instances is the exponential distribution, which we have seen before, with a certain mean inter-arrival time between two process instances. Moreover, it is not the case that process instances are created all the time. In many cases, process instances are just created during a certain calendar. Like, for example, new loan applications are only received or launched between Monday and Friday from 9 a.m. to 5 p.m. Or in other cases, it might be that in some processes, instances arrive on a 24/7 calendar. So let me take the working example, and second and third steps, as mentioned before, are second, to define the branching probabilities for every branch coming out of a decision gateway, and third, to define the arrival rate. Let me assume in this example that the arrival rate is 2 applications per hour. Note that this is a rate. We're saying how many instances arrive per time unit. In some simulation engines, it is more common to use the inter-arrival time. Let's say, give me a time unit, for example, the hour, and tell me how many units of that time unit it takes between the arrival of 2 consecutive process instances. So 2 applications per hour means that there is 1 application every 0.5 hours. In other words, inter-arrival time is the dual of arrival rate, 1 divided by arrival rate. Then you have to specify what is the probability distribution of the inter-arrival time. Let's say that the inter-arrival time follows a negative exponential distribution. This is also called a Poisson process in this case. Then we have to specify the calendar of arrivals, which let us assume is from Monday to Friday from 9 to 5. This means that new applications in this case arrive, at a rate of 2 an hour, averaged over a long period of time, meaning 0.5 or 30 minutes between every 2 arrivals. But it might very well happen that sometimes it takes 35 minutes between 2 arrivals, but sometimes it takes much more, like 55 minutes between 2 arrivals or more. Or sometimes 2 process instances might arrive just one after the other.